mostly this presentation now in a couple, three places. I got invited this started, I think, last December. Dallas, amazingly, the architecture firms of Dallas got together and did a year-long series on the 2030 challenge and the 2030 commitment through a series of lectures and talks and workshops. And I had not thought of that as a hotbed of climate change sensitive design, but they're really kicking it and doing some amazing things. And so I was part of that process. And then since that time, I got asked to go to San Antonio and 3 or 4 other places to present this. And this year, I've been serving on the AIA Committee on the Environment Advisory Group nationally. And we're all kind of fanning out, trying to spread the gospel about what's going on here, what various firms are doing. So thanks for coming. And what I want to do is just try to introduce what's up, how we suck, how we are all going to get better, and how the only way to get better is if more of you participate. So it's for the AIA credits, so there are learning objectives, which we never read. I'm with SQ Dumas Ripple, most of you know. EDR was privileged to be named by the AIA with the Firm Award in 2014, which is really just a recognition, not that it's necessarily the best architecture firm in the world, but it is one that perhaps is doing some things that are worth taking note of. And some of the things that we're proud that we're doing is our work on community engagement, our work on energy, our work on research, and our work to spread what we've learned within the profession. So we're very proud of the work we do. We like to try to make beautiful buildings, like I hope all of you do. And what we're trying to do is live up to, I think it's David Lake who coined this phrase of Lake Plato, that if a building isn't beautiful, it's not performing. And if it's not performing, it's not beautiful. And so how can we as architects try to integrate those two notions? And so what we've taken to is whenever we show a pretty picture of a building, we have to talk about its energy use or its water use or something with equal fervor. Although, as you can see, we give more real estate to the picture than we do to the text. This is the Bioinnovation Center on Canal Street. It opened in 2011, and we have been measuring not just the modeled energy use, but we have been measuring the actual energy use of this building. And we're proud to report that it uses 1/3 as much energy per square foot per year as a typical laboratory building, despite the fact that we have a pretty challenging climate for a lab building because of how much air you tend to move through labs and how much energy it takes to condition that. So yeah, we're very proud of a few of our exemplary buildings. But to be more clear about it, in some sense, we're just like every other firm. On the other hand, we have this kind of contradiction. We want to be a green firm, but we also need to stay in business, and we're doing a lot of various kinds of work. So we're proud that we're a green firm. We've got 6 LEED Platinum projects. One of them they've built 8 copies of. About half of our staff are LEED accredited. We can do in-house daylight modeling. We track the actual energy use of our projects. But on the other hand, we're not really that green. This percentage keeps falling, and now less than 10% of our projects are pursuing LEED certification. Some of our mechanical, electrical, and plumbing partners can't do energy modeling in-house. They resent that we ask them to consider it. And not only are some of our clients uninterested in sustainability, but some are downright hostile. I've had more than one client say, you can do whatever you like, just don't use that word, the S word, in my presence. You can't talk about sustainability. So what I'm going to talk about today is the 2030 commitment of the American Institute of Architects. And it's a commitment to track and report what you're doing. It's not a legal obligation to achieve a particular result. Obviously, it's going to be affected by what's realistic in your climate, in your political climate, as well as your meteorological climate. Then I'll talk about how different firms that have made this commitment are organizing their practice to try to achieve these results, to track and improve. And these are the kinds of requirements that we'll be going through. Is you develop a thing called a Sustainability Action Plan. You try to walk the walk as well as talk the talk. You change how your firm operates day to day. You track the performance of all the projects in design. And then they make available to you various tools that can help you raise that performance. And then finally, we'll talk a little bit about how to make the case for doing this kind of work for clients who don't know yet that they're interested in it. So signing up is really easy. There are about 300 firms have signed up so far nationally. And you just go, if you just Google 2030 commitment AIA, you'll land on this page. You click on join. Somebody signs a letter. In this case, it turns out I joined Eskew Dumas Ripple. I like to say I wasted the first 49 years of my life, and then I moved to New Orleans. But about a week before I joined EDR, Alan Eskew signed at the behest of the business development lead at the prodding this letter of commitment that says, hi, as a firm, we commit to do all the things that you ask us to do. The AIA asks that within 2 months you establish a sustainability team within your firm. Within 6 months you pick actions that you can implement within your firm that improve and kind of raise awareness of what's going on within your firm. Within a year you develop a sustainability action plan. I'll talk a little bit about that. And that annually you report your design portfolio, meaning the projects that were in design in that last calendar year, how are they doing? And then you report that information up. Now it gets reported anonymously, and so it doesn't have to be disclosed to the world, but they then aggregate this data and from that start to get a sense of how the whole profession is coming along. So under firm operations, I'll just give some examples. There's a huge laundry list. You can track and report the energy use of your own office. You can do simple stuff, agree that you're going to purchase Energy Star appliances and computers. Back when it was started, this was sort of a big shift to get rid of cathode ray tube monitors and go to flat panels. Obviously, it's kind of been long since surpassed, and getting rid of the last incandescent light bulbs. I think we had more MR16 halogen bulbs in our office than we could have made toast, but we slowly converted to LED and so on. You can establish a timeline for how you're going to move towards purchasing green power for your office operations. This is all about, you raise awareness through these kind of symbolic gestures. I've heard somebody say that, I heard this great talk by a guy working on sustainability at Caltech, and he had been trying to get the scientists to lower the sash on their fume hoods because huge amounts of energy get used just being thrown away through a fume hood that's left open. What you don't know is huge amounts of water get wasted because the way you make the cooling to cool the building is you run a chiller, and the chiller have those cooling towers that use water. It turns out 3/4 of the water in Caltech is not used for landscaping, it's not used for toilets, it's used to run the cooling towers. And so the way to save the most energy at Caltech is to close the sashes on all of it because they're a scientific institution. There are thousands of fume hoods. If you could just get them to close the sash, then they would save tons of water. So they went to the scientists and asked them, please start closing the sash when you're not using the fume hood. And they said, I'm not going to do anything like that until you stop watering that lawn out front. And I want to see that grass die before I have to change my ways. And so they did. And what the guy said was sometimes you have to do the symbolic before you do the substantive, right? And so in this way, this same way, the AIA is asking firms to do symbolic actions that just raise awareness, and then you can start doing some of the more substantive things like changing the portfolio of what you design. A lot more list, picking environmentally friendly, cleaning supplies. One thing that we did was we were trying to get our CFO to let us only purchase recycled paper, and she said, but it costs more. So we said, if we use 20% less paper, are you willing to spend 10% more for the paper that we buy? And she said yes. And so this business of tracking use, the number of sheets of paper we're printing, and then altering what you're doing based on that. Establishing transportation policies that are promoting less carbon impact. I was on a tour of a net zero office building at the National Renewable Energy Lab. And part of the tour was they took us on a tour of their sustainable parking structure, which was because they had built the National Renewable Energy Lab out in the middle of nowhere. And so everyone had to drive to get there. So then they had to have a sustainable parking structure that used less energy for lighting and so on and had good cross ventilation. That was all very nice. But the guy I was walking next to did a few quick calculations, and he said, if we take the actual average energy use of an office worker, meaning the amount that it takes to run a standard office, works out to about 300 square foot per employee. So you know the energy use per square foot of those offices, you add that up, you can work out what the carbon footprint is to run a standard office building in the middle of nowhere, or a standard office building that was right downtown where everyone could walk to work. And it turns out that if people commuted by walking or biking, that saves just as much energy as if their office building was a net zero office building, right? So where we build matters as well as what we build. And so in that regard, in our own firm, we made a very simple tweak. As part of the benefits package, we changed and made it so that everybody was automatically a member of the health club that's in the building. So now we have showers available. And there were some of us who biked, but some of us were more fragrant than others after we biked. And so having the availability of free showers made a difference. And from that, we find now that half of our staff commute by walking and biking. So lots of other firm operations that you can change, promoting meeting as often as possible, using WebExes and so on, rather than necessarily flying everywhere. Within 1 year, though, the next step is to develop a sustainability action plan. And there's no prescribed format. I wanted to know, how do I do one? Well, I went online, I looked at BNIM, very famous environmental leader. It was 275 pages, and it included plans for the carbon impact of the employees' pets. It had everything covered. On the other hand, I went to Lake Flato, another leading environmental firm known for their sustainable modern design, and it was a 4-page Microsoft Word document. There is no requirement for what you have to do. But the neat thing is that they make them available online. You post them, and so you can download other people's plans and find out what they're doing. And that became a roadmap. We did, I think, a 12-pager at first, and then after a year, we went big and went for 20 pages. And it was just, you go through all the different things you're going to be doing to try to improve your firm's own operations and the performance of your portfolio. And then you can also see on this little kind of Hall of Fame, Hall of Shame, the names of the firms that have signed up. You can see if they've made their firm operations changes. You can see if they have a sustainability action plan. And you can see if they have reported their firm performance. You can't click on that one because the idea is that what you report up is thrown into the bucket and anonymized. So how do we keep score, though? Ultimately, what we care about is what we're designing and what the consequences of what we design are. So there's this acronym, which I will now confess about 7 or 8 years ago, I didn't know what it stood for. And now I can't meet a person without having conversations about EUI. And in fact, starting this year, I've had now twice. The first time I met a client, a major university client, 2 different universities, the person I was with said something about hi, we're SQ Dumas Ripple. We care about high-performance buildings. And the head of operations turns and says, really? What's the best EUI of your most recent building? And I said, 27. And he goes, OK, well, then we'll keep talking. And so EUI, energy use intensity. So if you have your home utility bill and you add up for the year, this is the average house in America, uses about 12,000 kilowatt hours of electricity, and it uses about 800 CCF of natural gas. Well, wait, how do I add gas use and electric use? Well, one of the things the British left us with, although they no longer use it, is the British thermal unit, the BTU. They laugh at us when we quote things in BTUs, but it's sort of their little gift to us. So it turns out you can convert the energy content of electricity to BTUs and the energy content of gas to BTUs. Then you can add them up, and you get a total number of BTUs. It's just an energy unit. And then you divide by the area of the building. So if you have a 2,000 square foot house, divide that into that, and you get 60 of this terrible-looking unit, kilobTUs per square foot per year. Some people just say the EUI is 60. Of course, then if you try to compare with Britain or Canada or such folks, their units will be different. That number then, going forward, you have to learn that different building types have different EUIs. So multifamily residential, the EUI of an apartment building might be around 50. Single-family houses around 60, offices high 60s, and so on, libraries more and more, laboratories 370. So when you're comparing your building, what you need to make sure is you're comparing with like for like, right? Because you'll see wildly different EUIs. Now, Ed Mazria, the founder of the 2030.org, came up with this idea. He said, we already know, just looking around, back in around the year 2005, he said, we look around and we see architects all over the world who are able to make buildings that use half as much energy, just by paying attention, which way the building faces, reasonable amounts of glass, and so on, reasonable levels of insulation. what if we said, we're going to make the target that says all of our projects in our portfolio, we're going to aim to use half as much energy per square foot as the average building in the government survey done back in 2003. 2003 was the last time the data was handled correctly. There was another set of surveys done through the Bush administration, which they then realized they had cut the budget enough to the point that it wasn't statistically significant, so they threw all that data out. They've done the next round of data under the current administration, but the results are just starting to be promulgated. But the nice thing is this is kind of our starting point. And what he said was, what if we said, in 2005, we're going to try to make all of our buildings in our design portfolio use half as much. And then in 2010, the projects in our portfolio 40% as much, then 30%, and so on. So it's basically doing the limbo. And the idea is that each year we should be learning and getting a little bit better and a little bit better. And our goal is to have net zero buildings by 2030. Now, if you look at this, you realize that on average, this might be true, that we could make net zero houses. So in fact, in California, under Determinator, they made a rule that all houses would be net zero by 2020. Because as it turns out, you can make a net zero house. It's pretty simple with covering a small fraction. My 1880 shotgun Camelback house in New Orleans with just a little bit of extra insulation and only 300 square feet of solar panels is essentially net zero. And so that's not hard. Making a one-story building or a two-story building of a low EUI building type, getting to net zero, easy. Making a multi-story laboratory, net zero, hard. Probably, maybe never going to happen. Certainly not going to happen easy. And so, but the vast majority of what we're building in the world are things like this. And in fact, the average height of the building built in America last year was 1.1 stories, right? So there's kind of no excuse. Now, we want to build denser, we want to build more urban, but in general, there's no reason why we shouldn't be able to get to that net zero goal for the vast majority of building types. Now, as soon as you learn about this metric called EUI, you all remember Steve Martin used to have stupid pet tricks. There are stupid EUI tricks you can play. For example, if you just take the survey of houses throughout America back in 2003, and you plot their energy use, their total energy use, what you find is, of course, every house has a kitchen, every house has a refrigerator, and so on. So there's, in a sense, a fixed amount of energy you kind of almost have to have because of that overhead of the things that use a lot of power. But as houses get bigger, most people only have one kitchen, and so on. So what happens is that the energy use kind of, that curve sort of bends over a bit. And what that means is that the energy use per square foot just naturally gets lower as buildings get bigger, as houses get bigger. And so we'd like to encourage people to live compactly, use fewer resources, allow denser housing, and so on. But in fact, if you just take the EUI number for average residences, you'll be penalized in a sense. It's harder to make a low EUI small house than it is to make a low EUI big house. And so my friends at certain inspirational firms that make luxury houses for the environmentally sensitive have kind of a built-in advantage because they're just building a big house and already that number is going to be low. So it's important that we measure stuff, and it's important that we know that whatever metric we use, there are going to be things you go, yeah, but that's sort of cheating. Well, at the end of the day, if it's zero, it's zero. So it's not all that hard. In the case of single-family houses, we have this challenge that over the course of the decades, houses keep getting bigger. And so and EUI will drop for free just because the houses are getting bigger. So we shouldn't over-congratulate ourselves. Now, starting 2 years ago, the board of the AIA made an interesting rule. They said when you submit for a design award, Faith and Form, any of those kinds of awards, there's a little slot where you fill in the energy use intensity of the building. Steve Dumez, the director of design, came over to my desk and he said, I think I have to be your new best friend now because I can't win a design award unless if I leave it blank, they're going to think I'm hiding something. So I need to find out what my EUI is for any project, even if I was just trying to win a design award, right? And so if we think what motivates most architects, A, we want to stay in business, and B, we'd like the respect of our fellow architects. We'd like to win design awards. The only way to get there, you don't have to be the wacky environmentalist architect Enviro Nazi that I am to know that your path to success has got to be to improve the energy use intensity of your buildings. So you do annual reporting. And there's new construction where you talk about the energy use of your whole building. But the other one is this thing called LPD, the lighting power density. If you're doing renovations, about half our work, how many here people do renovation work, right? So about half of our work is renovation work. And what they said is, sometimes when you're doing the renovation, you're not changing out the building envelope. You're not changing out sometimes even the mechanical system, maybe just moving the terminal units around. The one thing that's almost always in your control is the lighting. And so what they said is, well, we could ask you to do a simulation of how much energy the lighting's going to use over the course of the year, but then that's a big modeling thing. What's a really easy to do thing? Well, what if we just added up the power of all the lights if they were left on, if they were all running full bore, and just take the total wattage of those light fixtures and then divide by the floor area. So that's lighting power density. And so if you are a signatory to the 2030 commitment, what they said was in 2015, you were trying to get to 60% energy reduction for new construction. But they also said you're trying to get in your renovation work to a 25% reduction compared to the lighting power density limits that are in the building code, ASHRAE 90.1 2007, which just happens to be the building code that we use still in Louisiana. So when you're working with your electrical engineer or lighting designer, we've gotten to this point where we try to say, here's the space types in this project. It's a restaurant, it's a this, it's a that. Here's your budget for how much lighting power you get to use by code. You really only get 25% less than that. And they scream and they hem and they haw, but they just pay attention. And what we found in general is that if they're careful with where they put the fixtures, they don't have to kind of brute force and throw so many fixtures at it. So we actually save first cost as well as overall energy. Now, every year people upload. It used to be that you did it by, you filled out a spreadsheet and you emailed it. These days now it's all handled through an online web reporting form. And you can look at it continually to see how your firm's doing. So it's not like the old Johnny Carson skit of The Amazing Carmack where you open the envelope to find out how you did. Here we always know how we're doing. That said, once a year they kind of scrape through the data that's been uploaded in this database, and they produce a report on how we're moving towards the 2030 commitment among all the signatory firms that are reporting. And so here's the first thing. This is the total square footage of that was reported in the design portfolio for reporting firms in 2010, 2011, and so on. In 2014, it was 2 billion square feet are being reported by the signatory firms. To put that in perspective, there's 60 billion square feet of commercial space out there, and about 170 billion square feet of residential space. So it's still it's the tip of the iceberg, but these are the leading firms that are signing up to to participate. Now, in fact, who's signing up? Well, this is showing you the number of firms that have signed up for the AIA 2030 commitment, and in each case, the green bar is the most recent year. And what we're seeing is a lot of firms that are in the mid-size and sizes of 50 to 100 employees, 100 to 500 employees. More and more are signing up. And then the firms that have like 1,000 employees are signing up. There aren't that many of those firms, right? But all the big firms, when you look at the list of signatories, it's all the firms you've heard of have signed up. And what you're not seeing is a lot of small practices signing up. EDR signed up back in 2009. It's our ambition to get at least the 3 biggest firms in the city to sign up. We'd like to get a few more. Now, how are we doing? The answer is we suck. The answer is this is the total portfolio savings compared to, this is kind of a funny thing you have to get your head around. You take all of the buildings that you're working on in 2014, and what you say is, what if you're doing a K-12 school and it's 50,000 square feet? You look up in the lookup, it looks up for you, and it says, oh, 50,000 square foot K-12 school in your part of the country, the average school that existed in 2003 used this much energy use per square foot. So I'm going to multiply that out and tell you, here's how much energy your average school would use. Now, report out, what does the energy model say your school's going to use, right? And you say, but I can't do an energy model. My mechanical engineer never heard, how can I do such a thing? Well, in that case, what they tell you is you tell us which building code you're building it to, and assuming you're meeting code minimum, they know that as building codes advance, we can expect a certain degree of savings. In Louisiana, we're under ASHRAE 90.1 2007. That's averaged over all building types. It's about a 25% savings compared to the average building that was out there in 2003. So either you put in the number that you actually modeled, or you just assume it's 25% according, under our building code. So back in 2010, they looked at and they said, this was the very first year they had reporting. They said, well, it's not the end of the world. We're seeing 35% reduction in predicted energy use. That's not bad. But of course, you'd get 25% just by having built buildings to code. So, well, that's not all that impressive. And in fact, the other thing to point out is that it hasn't really budged very much in the last 5 years. So what's happened is now, though, we have enough data on enough firms and enough projects and enough building types to start to analyze why, what's going on. Let me say one other thing before I move on. How many projects met that 60% reduction goal in their portfolios? And it's not how many projects, it's the project area, right? So the 12% of the portfolios dropped to 7. Recently, it's up at 11. The answer is only about 10% of our 10 to 15% of people's portfolios. Now, there are a few firms, we hate them, that 100% of what's in their portfolio is meeting that 60% reduction goal. But they've got those clients we would all kill to have, who really care. It's very important. That, it's part of their values. So what are we going to do when we have just mortal clients, right? Well, this year they started to do deeper dives and analyze. And this graph takes a little bit of looking at to understand what it's saying. But what they said was, they looked at, they threw all of the buildings of that, 2 billion square feet that were into a big bucket, and they did a statistical analysis and threw out the outliers. And what they found was the percentage energy savings for the projects that were just say, tick, 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 I'm doing a code minimum. Some of those projects are in more, states with more aggressive codes than others, right? So there's this spread, and what they're saying is this is the savings for the projects that just said I'm building code minimum. Then they said, what about the ones where you modeled? And this one's kind of weird to look at, because what it's saying is that for certain projects, the modeled energy use was not saving compared to the average building out there. It was actually going to use more energy, right? And that's because you might be doing a building that the average, let me say, data center might be open, or the average university building might be open 8 hours a day. But what if your building is open 24 hours a day because it's the computer center? Well, it could be you add up its energy use, it's going to be huge compared to the average university building. So you won't see savings. That one building is going to look really bad compared to the average university building. So you see these huge spreads. All that said, this is undeniable. The projects that are doing energy modeling are seeing larger savings than the projects that are not. And so what I'll be talking about a little bit is, okay, how can we start doing that? Partly this is, there's this old saw that says you can't manage what you don't measure. And the variant of that, for those of us interested in weight loss, is the pencil diet. You can eat whatever you like as long as you write it down, right? Because the effect of, I did have 2 of those cookies, not 1, right? The fact that you write it down changes your behavior. And so the fact if we start looking, and we looked at our own portfolio at EDR in 2014, and we found, just like they said, the average, if we added together all our projects that were built to code minimum, we were getting a 25% savings. That's really just an assumption. But then we looked at those projects in our portfolio that we were doing energy modeling on, and we were seeing an average of 43% savings. So what this says is if we're paying attention to it, we'll do better. So how do we make it so that we pay attention to more stuff? So one of the things that we've done internally is most firms have a process, a checklist of when I'm at schematic design, when I'm at SD, here's what has to be true. I have to have done this much. When I'm at design development, I have to have all of these elements worked out. Do I have the site plan? Do I have this? Do I have that? What we've done is we've enumerated that list of all the things we need to have in place before project teams get to start billing to the next bucket in the fee. And we've incorporated performance goals into each of those phase gateways. So when you're starting out and you're just sort of saying, hi, we've got the client, we've got the letter agreement, let's get started. And so the first question is, okay, what's your building type? It's K-12 school? Okay, the average K-12 school was here. Here's your goal. You don't get to move on to SD until you at least know what the average building is and what your goal is if you're going to try to achieve 60% savings. Now you go through SD, and it's like, okay, at the end of SD, how you doing? Well, we can't do a detailed energy model. We don't even know if we're doing VAV or VRF or EIEIO. It doesn't matter. You should be able to understand how your building envelope's doing. You've made your initial move about, what are the insulation levels and so on. So our goal is that as the project moves through the design cycle, we know with greater and greater certainty what that energy use is going to be. So how do we get clients who aren't necessarily interested in high performance to get interested in high performance? Sometimes it's the dollar value. But remember, for example, if you're building an office complex, the average office building owner is spending 3% of revenue on energy. They're spending over 85% on salary and benefits. And so what really matters to them is the salary and benefits, if you could affect that, right? But everybody cares whether they're at the top of the heap or the bottom of the heap. So this is a little shot from when we're working. There's Dickie Brennan and his head chef from the Palace Cafe. And he was sure, because he'd installed a variable refrigerant flow cooling system for his kitchen about 2 years before, that he was at the top of the heap in terms of energy performance. And we said, oh yeah? Do you have your bills? And he said, he points to some junior guy who's kind of like this. He says, get them the bills. And like the next day, the bills appear on my desk. And we do a quick analysis. And we say, OK, here's the national median. We put it in dollars just to make it easy. Kilobits are confusing sometimes. Here's the average restaurant spending $3 a square foot per year on energy. You, Mr. Smart Guy, are spending $6. So he goes, OK, now you've got my attention. And the next, I didn't quite say it that way to his face. But then suddenly we had his attention, because he said, I am at the top of my game as a restaurateur. I'm not going to be below average in terms of the performance of my building. What do I have to do, right? So it was finding the part inside your client that actually, what does he care about, or what does she care about? So once you've got 12 months of utility data, you get there's all kinds of kind of hidden mystery information buried inside utility data. This is a plot of the average. This is the gas use in his restaurant versus the average monthly outdoor temperature, and this is the electric use. And what you're seeing, not surprisingly, is when it gets hotter, the electric use goes up. When it gets colder, the gas use goes up, right? So far, so good. But what's really interesting is that there's this sort of every month of the year, there's this kind of base load that's always there. Well, he's a restaurant, right? So he's got lighting that's going to be on no matter what. And he's got, this is cooking. He's going to be on. He's also got fans that are on a certain number of hours a day, right? So right from that, you can say, oh, that's telling me that if I sweat nickels to, like we talked about, oh, maybe we should put in special low-E glazing and reglaze the front of the Palace Cafe. Well, right away you look at this and you say, knock yourselves out, it won't make much of a difference, because what's dominating his energy use is what's happening in the kitchen. So then I got to learn and make new friends with the kitchen designer. And I said, yeah, I want the architecture to be great. I want the lighting to be inspiring. But I also want to make a difference on this number. And the only way I'm going to make a difference on this number is if I become your best friend, Mr. Restaurant Designer, Mr. Kitchen Designer. We started talking about, oh, well, the fume hood, you have to do the makeup air this other way then. If you actually cared about this stuff, here's how you do it. So that notion of that there's a ton of useful data, there's gold inside 12 months of utility data. There's also resources which the government, in their wisdom, puts out every year, amazing design guides that say, we've gone and looked at 500 restaurants that have done retrofits or rebuilding and so on with various strategies. Here's what the average restaurant uses. Here's the strategies that really work. And they've done that for restaurants. They've done it for K-12 schools. They've done it for university buildings. They've done it for office towers. They've done it for every building type you can imagine. You can download these guides for free. So we then said, OK, if modeling builds our performance, what if we work hard to make energy modeling easier within our firm? And so in the last 3 years, we've invested, and we've actually hired somebody on staff who can do energy modeling in-house. We've also put the screws to our mechanical engineering partners saying, if you're going to be with us, here's where we're going. Wake up, smell the coffee. And we've tried to make tools that make it easier to do energy modeling even for everyday architects. And by doing that, our average firm performance is going up. So there's that old book, Architecture Without Architects. This is energy modeling without energy modelers. So there's a lot of tools out there that are free. There are some that are intended for architects to use. They're very graphical, very friendly. There are others that only the nerds on your staff will be able to make heads or tails of. So there's a lot out there. And we'd be interested in forming kind of a discussion group between different firms that are playing with different tools, which ones are working for you. Another thing we've done is we've tried to organize our firm in ways that can reinforce performance improvement. So at EDR, we have a technical staff of around 35 and divided into 5 project teams. On each project team, what we've done is we have singled out a person we call the sustainability champion. It's, Mark Twain once said, always obey your parents when they're in the room. And the difficulty for the sustainability advocate within a firm is that you can't be in every design crit. You can't be in every client meeting. And as soon as you leave the room, all those things you were arguing for can suddenly become of lesser importance than whatever somebody else was arguing for. So you need somebody who's always in the room. So what we've done is we've invested in training for these sustainability champions on every project team out of the hope that they can advocate for those things. At our firm, my job is to beat people up at the principals table, to making sure that that performance is a priority for all our projects. And then we went and hired someone we call the sustainability enabler. A sustainability enabler ideally is more like a personal fitness coach. He doesn't lift the weights for you. He shows you what you're doing wrong, how to lift it better. And so he's a coach who does training with the sustainability champions. And also he's a resource, that when you say, I need the hemi-unitable spherical rod end simulation, he goes, oh, I've done one of those this morning. And so can do kind of very sophisticated energy modeling or hygrothermal modeling, understanding how moisture moves through a wall, different things like that. And so these are our champions. And we have little bake-offs from time to time. And the idea is to test out your skills. If you're just each working individually on your projects, that's one thing. But occasionally we will take a topic and say, OK, so-and-so just came up with this idea how to do a big box store in a downtown region, but we didn't pay much attention to daylighting. So let's explore how would the building form change if we cared about daylighting, and let's look at the consequence for daylighting and consequence for energy use. So this was using a tool called Sapphira that lets you do both of those things. And the various people we met one week kind of said, OK, you take this strategy, you take this strategy, you take that strategy, you take that strategy, come back, knock yourselves out, and we'll see who got how far. And that's a way to kind of test out your skills with a common project base. But with energy modeling, it's easy to spend, energy modeling is sometimes, especially when you're doing it with really sophisticated computer simulation, it's a way to get the wrong answer to 4 decimal places, right? Meaning that it's only as good as what questions you're asking. And also, sometimes people spend an awful lot of time agonizing over things that make very little difference. So this is an example a colleague of mine sent. There were these huge arguments about which glazing they were going to use in this building, assuming they weren't going to change the amount of glazing or which way it faced. Just should it be Viracon VNE 1363 or Viracon 132M? And the answer was a 0.37% difference in predicted energy use. Immeasurable, really. But if you're not careful, you'll spend all your time optimizing the wrong stuff. So the goal is to find out what is the right stuff, what's the important stuff. And we'll talk a little bit more about that in just a moment. One of the other things we've worked on is realizing and trying to advocate for better, more efficient lighting is that there was, in a lot of clients, resistance. They said, I'm not sure that that lighting, they once bought a CFL at Home Depot and it made their kid look green, and so they don't like fluorescent lighting. So lighting quality obviously really matters for client acceptance. And so recently we did a thing where this was again for a restaurant project where we built a simulation inside the middle of a room that had no windows in our office, and thought it was appropriate to put out a fine bottle of wine. We've never found the bottle of wine since this day, but a little wine, a little food, because again, this was a restaurant that cared about how does food look under that light. So we got a bunch of vendors to send us lights. We made a little mock-up thing, and we could turn them up and down and try different lights. And that's the client sort of going, giving in a sense a taste test, of his direct experience. And using that, we've been able to convert a lot of our clients to much more efficient lighting choices because they have the confidence that this will work for them. There are other tools that can make it easier. You don't even have to do a simulation. There are these things called Advanced Energy Design Guides, put out by ASHRAE jointly with the AIA. They're available for download free for all these different building types. This is the design guide for if you're doing a small to mid-rise office building. If you just follow this paint-by-numbers approach, use this insulation, this kind of mechanical system, use about this amount of glass, and so on, we will get you, on average, 50% savings compared to the 2003 baseline. What could be easier? So what we try to do is every project, when we first meet at the kickoff, we say, start here. This is just a starting point. You still have design freedom. You've got lots of choices. But within that range, you ought to be able to make choices that get you to pretty good performance. So as an example, we had a project. This is a project under construction now for Tulane, where it's a hybrid building. It's got a laboratory, it's got offices, it's got meeting rooms, and it's got a big public education center. Finding what the benchmark of that building is a real challenge because it's sort of a mix. It's a real mutt. And it's only about 6,000 square feet. And so the amount of fee that's available for our poor benighted mechanical engineer who is capable of doing energy modeling, they said, please, for this fee, can we just do one energy model? And we said, OK. What that meant was we did a little bit of energy modeling during the design within the architecture team. But when it came time, we got to we were 50% through CDs. We said, OK, it's time for that energy model. And they sent us the results. And the cover letter said, here are the results, but we don't believe them. And I said, and why is that? And they said, well, we've never seen a building with this level of energy savings that didn't have solar cells on top. And your building doesn't have solar cells on top. So we just don't believe the energy model. And so we kept beating on them. And they said, well, actually, you're right. In fact, it's not 44%, it's 45%. Once they did it, and they said, what did you do? They asked us, and well, we didn't overglaze it because we couldn't afford to overglaze it. We paid attention to where where it was going to face west. Those are in deep pockets, so they're not going to get too much sun drive, and so on. And we paid attention to how we're doing the ventilation. So. The point is that and this was all done using those AEDG guidelines, those Advanced Energy Design Guides, and a fairly standard approach for HVAC. Now, the next level out is in energy modeling without energy modelers is I have the rare privilege to teach the kind of entry-level building science course for the Tulane School of Architecture. And in that class, you teach them, here's about how heat moves to the wall, here's how sun comes through a window, and you can calculate the energy impact of each of those choices individually. And then finally I got to a stage when I said, I can put this all into one spreadsheet. And this spreadsheet I call the way too simple energy model. So it's a thing that lets you just go through and consider two versions of the same building where you change hopefully only one thing at a time, and it will calculate a very, very crude energy use per square foot for the building. It turns out that it gets it right most of the time in an embarrassing fraction of the percentage. It won't get right if you have like a super duper insulated building that has incredible amounts of glass where the thermal swings might be huge. But for typical construction, it will do pretty well. And if you contact me by email after the talk, I will happily mail you a copy. So that's where we are in design. That's all very good. But it turns out, how I showed you that little chart where we were optimizing and changing the glazing type and only changing by a few percent? What if I were to tell you that what will really make a huge difference in your buildings has nothing to do with the design choices? It has to do with how the buildings will be operated. And so we set about, EDR has a thing called the Research Fellowship. And the first year of the Research Fellowship, we had the research fellows call up all of our clients who wouldn't hang up the phone on us and ask them for their utility data. And it was amazing how many of them are willing to do that. And it's amazing how many of our clients are behind on their utility bills. But we don't share that information. But we were able to add up the utility data, divide by the square footage, and get the EUI numbers. And then we looked in the tables to find out what the median were for those building types in yellow. And so we have this Hall of Fame, Hall of Shame. And we've had this as an internal document, and now at the prodding of our business development director, we're about to go live and make this public, where we're talking about this because we think that the key to making progress is transparency. So from this process, and this is me working with Tulane students, we're crawling around inside. This is Sean Prale, one of my coworkers. This is his house, and they're instrumenting his enthalpy recovery ventilator. This notion of measuring buildings and looking at the consequence of design choices in terms of building performance and in terms of occupant comfort. That's at a key in the class at Tulane, and it's also a key of what we're trying to do in the firm. So what matters ultimately isn't model DUI. Model helps you make design choices, but the real proof will come in measured performance. So we're getting better at doing this. This is a chart of a bunch of projects where here was what the computer model said, and here's what they measured the buildings to be. And then what happened was they went back and they said, well, maybe when we did the model, we didn't realize that your building was going to be open 18 hours a day rather than 12. So let's rerun the model with the right occupancy. And maybe we didn't realize that during construction, the contractor didn't put in all the insulation that we'd specified. He kind of cheaped out on the roof insulation. OK, well, so let's correct that and rerun the model. So these orange triangles are showing you, after they did the best they could, adjusting the model to be true to everything they now knew about the building and how it was being operated and occupied, what they found was they are now able to get about 2/3 of the variation in actual performance is predicted by the model. There's still 1/3 that's something else. And the something else can be things that are going wrong in the building, little changes, and so on, things that aren't captured by models well. So we got contacted by Make It Right. We designed one of the prototypes that they used throughout in that neighborhood in the lower 9th Ward. They said, congratulations, your house won the prize for the lowest EUI of any house at Make It Right. And we said, we must be geniuses. This is great. This is due to our superior design capabilities. And so this is the electricity used. This is the electricity produced by the solar panels on top. And that's the little gas used for the tankless water heater in the cooktop. So far, so good. And I said, this is great. The average EUI of a single-family house in our region is 42. This one's 3. Yes. And then I said, wait a second. At this point, this is 4 or 5 years ago. And I said, they built more than one of those, didn't they? And I said, yes. So we went and instrumented. The second one we instrumented was the second highest energy use per square foot of any house in the lower 9th Ward. So then we like, whoop, 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 and instrumented the building trying to figure out what was going on. And what we found was there was a series of issues going on with the mechanical system and how it was being operated. And by changing those and fixing those, we got the energy use down and actually the air quality up in that building. But we wouldn't have known. And so, is it the architect's fault? Yes, or the design team's fault? Well, yes and no. It's the design team's fault that we make buildings that are so opaque to the occupants that this guy had no idea that his building was malfunctioning and performing poorly compared to somebody else's. And that's the importance of benchmarking. If you knew that your house, which is identical to the one down the street, is using literally 20 times as much energy, right? You'd go looking, right? And so the challenge is it's not enough to say, hey, I've got a LEED Platinum house here. They both have LEED Platinum houses. But one of them, the way I've heard this described is there are no net zero buildings. There are only net zero occupants. So this is the importance of operation. We found this in a number of our commercial buildings as well. I won't go into the deep story of this, but just to say this was what we were expecting the building to use. This is down in Key West where there's relatively mild seasonal variation. And for the first couple of months it did. And then a series of changes in the computer program that was running the building got everything so far out of whack that the building used almost 3 times as much energy as was predicted. And that was when the mold bloom happened. And after the men with the bunny suits came through and cleaned up the mold bloom, and we reset all of the building controls to where they had originally been commissioned, the building has been running like a clock. In fact, it uses not 20% less energy than the baseline of code, but in fact closer to 40% less energy. So that notion is that we have to make, as architects, a kind of long-term commitment to looking. My mom used to say, no one likes to look behind the refrigerator because it means you'll have to clean there. And if you look behind the refrigerator of your buildings, you'll find sometimes you'll find a pleasant surprise, but often you'll find a problem that needs fixing. So how do we make the buildings that they don't wander off so badly and that they deliver the performance that's possible to them from day one? So we've turned up a bunch of efforts within the firm to do post-occupancy monitoring right during building handover. So this was the new SPCA building. Has anybody gotten an animal there yet lately? A companion animal? So we started monitoring the temperature through a bunch of rooms in the administration wing, and immediately found how some of the equipment had started to wander off, and realized what had gotten misprogrammed and how that was set, some valves that were set wrong, and so on. That notion of handling it really quickly early on can get the building operating right more quickly. The other thing that we found is that nobody understands how their buildings are supposed to operate. Because during handover, we often hand over the manuals, and they're about this thick. There's usually 4 or 5 or 6 binders that go in a building of any particular scale, and no one can make heads or tails of it. And so what we started to do, again, we're not yet paid for this, is to develop a kind of an owner's level owner's manual, not a nerd's level owner's manual, that just explains the basic principles. So this is for the Jazz and Heritage Center on Rampart, and it explains, here's how your building's set up, here's how it's supposed to be running, here's where the things are that control those things that are supposed to be running, and here's the behavior it ought to exhibit. And if it doesn't, there's something wrong, and you should call this person, preferably not the architect. But it is our goal. I mean, in some sense, I like to say that architects are sort of the C-3PO of the built environment. They're in human-cyborg relations, right? We've got the mechanical engineers and the contractors over here who don't speak owner, and you've got the owners over here. And the architect's job sometimes is to be this interpreter of the built environment, the one that matches what the buildings can do to what the owners and occupants need. And part of our new role, I think, as building systems get more and more sophisticated, is to kind of provide that beginning translation so that they can get their buildings to work to the level that they really are owed. So in conclusion, what I wanted to say was that signing up for the 2030 commitment is a great thing, because it's like the pencil diet. It forces you to look squarely and soberly at what you're doing and not just pat yourself on the back for you're the 1 or 2 buildings in your portfolio that are exemplary. Some clients are more receptive than others to what we're trying to do, but everybody likes savings, and everybody likes a building that actually runs well. Like a good crawfish boil, it's messy, but a lot more fun if everybody joins around the table. So I hope you all will sign up, and we're available to try to help you do it. So thank you very much.